Cersaa is the experimental testing center, the GAP-recognized testing center working in the field of minor crops. Cersaa is located in the middle of Alblinga Plain. We are located close to the French border and located in North Italy. Thanks to our climate condition, we can simulate several scenarios of application and disease control methods both in open air and under protected crops. Cersaa Testing Center born in 2008, so it's a relatively young testing center, but before activities were mainly focused on diagnosis, plant diagnosis on several crops, including minor and major crops. Thanks to this expertise, Cersaa Testing Center had the opportunity to enlarge the activity not only on the field of efficacy test, but also on the field of production and formulation of selected inoculum, particularly of fungi and bacteria. This activity made possible for Cersaa to have a better simulation when testing active ingredient, but had also the opportunity for Cersaa to sell in the Italian and European market such inoculum in order to help other testing centers doing activity both on minor and in major crops. Cersaa cooperate with several GAP testing centers located in Italy and abroad, and in the same area where Cersaa work, Cersaa also cooperate with the LabCam. LabCam is a GLP testing center, so is an expert in other field, but thanks to the opportunity to have these two centers very close each other, it was possible in the past and it is possible now to give to the customers, to the sponsor, broad activity and experimental activity that came from the GAP test to the GLP test. We are now located inside a protected crop where we are carrying out a trial focused on soil-borne disease. The target is Fusarium solani specialis cucurbite and the host is zucchini crop. This kind of trial need some special attention to the minimum number of plants we have to use inside the plots. The minimum should be at least 10 plants that can make possible to have a proper disease evaluation at the end of the crop and a proper crop development evaluation during the development of the trial. The number of replicates is another critical aspect. Generally, considering the rules reported by EPO, the minimum number of replicates should be 4 replicates. But we generally prefer to have, if possible, 5 replicates. So one more in order to have better robustness of our data. The specific trial we are seeing in this greenhouse will have the most important data collection at the end of the trial, because the disease we are considering, so Fusarium solani specialis cucurbite, is especially located in a root system. So at the end of the trial, all plants will be rooted up and evaluated at the root level in order to have a clear idea about the infection of the disease, and of course a clear idea about the protection of all different products and strategy we set. In this greenhouse we are evaluating active ingredient that is effective against soil-borne disease on melon, but that can be distributed and in the greenhouse through a drip irrigation system. This is a technology now widely diffused that can help to mitigate negative side effects of several active ingredients, but need a proper calibration of drip irrigation system compared to the crop layout you have to simulate. Variability is one of the most important factors able to affect the integrity of efficacy study. Now we are inside a high technology greenhouse, so theoretically variability due to climatic factor can be strongly limited. Nevertheless, it's a must to have always a replicate inside an experimental trial in order to limit and to mitigate negative side effects of variability. Particularly when the first symptom of a disease as well as a soil-borne disease is practically speaking a stunting, a plant stunting, it's really important to have more replicates of the same treatments. Technically, the minimum number of replicates should be 4, but practically speaking, in this condition, it could be useful to have 5 till 6 replicates of the same treatment in order to limit, to mitigate the variability, and particularly to have a clear figure about the effect of the treatments on the crop canopy and crop development.
Hi everybody, my name is Anna Lanteri and I'm a researcher in the laboratory of Cersaa. One of the activity that we have improved and developed during the last years is the production of artificial inoculum. Artificial inoculum is very important when you would like to improve the realization of your efficacy trial. But there are also several critical points in this kind of application because you have to choose the right kind of strain, the right kind of formulation for your application, but also the right strain to have in order to have the right symptoms. And you have also to go to apply the inoculum in a specific timing. About these critical points, we can give a support to the applicators. In our laboratory, we have a collection where we have collected a lot of strain from different crop systems, but this is related only to the pathogen that can be propagated artificially. In other case, we can suggest also the use of pathogens that you can't propagate. So, for example, in case of rust, the application of rust that have to be collected during the season and after applied. So we have also a collection of rust, but also in case, for example, of the application of peronospora or other pathogen like viruses that can be applied mechanically on the crop, but only if you have the pathogen on the live tissues. Here you can see different kind of artificial inoculum. For example, here we have gauzes embedded with nutrient broth, where Alternaria solani is grown. This is for the application on tomato leaves. In this case, we have fusarium in liquid formulation, and this is for the application on foliar system. But in this case, we have fusarium solid substrate. This kind of formulation is for the application in the soil, for example, or the application at the collar or during the transplant. In case you have to apply inoculum that can be multiplied on solid or an artificial substrate, we can provide also different kind of spores, for example for the rust, because we have a collection of rust in our lab, or for example in case of viruses, we can provide infected plants to be applied with a mechanical method directly on the leaves.